today's class, we are going to discuss problems on selections of circuit breakers. Previous class, we may come across the problems based on fault analysis based on your circuit analysis method and Thevenin's theorem method. A same problem is solved by your conventional KVL and Thevenin's theorem. And then we come across selection of circuit breaker theory portion, and then a flow chart of fault analysis using this. So these are all the contents we covered in the previous session. So in this session, I'm going to deal with problems based on selection of circuit breakers. So for this problem part, you should aware of that table. Previous class I told of table. So depends upon the cycle, the multiplication factor is varying. So the table we have to remember. So this is the problem we have. Problems on selection of circuit breaker. So a generator connected to a 5-cycle circuit breaker. This is the keyword you have. It is a 5-cycle circuit breaker. So multiplication factor is 1.1. If it is 8-cycle means 1.5. 5-cycle means 1.1. A generator, a 5-cycle breaker. Generator, and I just drawn here a generator. Transfer. So from generator to transformer, I am having my CB. So after 5-cycle interruptions, my power system is going to react. That is in the normal position. So the rate is given. So 100 MVA, 18 kV with the reactance. So subtransient reactance is 20%. Transient reactance is 25%. The steady state is 110%. So these are all information which is numerical information given in the problem. So power rating is 100 MV, kV rating is 18, reactance is both subtransient, transient, steady state is given. So it is operated on no load and at rated voltage. No load rated voltage will operate out. So when a 3-phase fault occurs between the breaker and the transformer, this is the breaker, the central triangle portion breaker, a transformer. So in the middle of the circuit breaker and transformer, you infer a fault. So that is your 3-phase. So now fault in types. So balanced only we have 3-phase. Balanced we have line to line, ground, and double line to. So 3 categories for unbalanced, 1 category for your balanced. So yeah. So in this situation, we have the 5 essential criteria. Subdivision A is short circuit current and circuit. To find out the short circuit current. Second subdivision is the initial symmetrical RMS current circuit breaker. And third one is maximum possible DC component of the short circuit current in the breaker. Fourth is the current to be interrupted by the breaker. And fifth one is interrupting MVA. These are all the 5 solutions we have calculated using this problem. So one thing you have to remember, the question is complex and lengthy means the solution is so simple. Get panic because of the question. So if you have the question, solution simple. The one thing you need is you should understand the question properly. So question கொடுத்தாங்கன்னா அது பார்த்தோன்னா பெருசா இருக்கு சார் அப்படின்னு பயப்படக்கூடாது. கொஸ்டினை கொஞ்சம் பொறுமையா படிங்க. என்ன இன்ஸ்ட்ரக்ஷன்ஸ் கொடுத்துருக்காங்க, நம்ம என்ன கண்டுபிடிக்கணும் அப்படின்றத இந்த கிளாரிஃபிகேஷன் வந்து உங்களுக்கு கண்டிப்பா தேவை. In case of problematic papers, that is the thing needed for any kind of problem. papers, not only your power system analysis. Any kind of problematic papers, you should first read the question properly. இதுதான் parameters அப்படின்னு வந்து முதல்ல வந்து அதை ரியலைஸ் பண்ணணும். The self realization of the given problem is much essential to solve the problem. Please mute your microphone, students. The recording session is going on. Don't interrupt with me. உங்களுக்கு டவுட்னு தனியா செஷன் தரேன். Please mute your microphones. 120 roll number 1, kindly mute your microphone. Otherwise, I will disable all the persons mic. Okay. So the question understanding is much important. You should understand the question. Do you need any clarification in the question? The question you doubt கேட்கலாம். Solution is simple. Solution ரொம்ப simple. Is it okay? The question is okay to everyone? Shall I continue further? The question is okay, ma?
Yes, sir.
Sorry, ma. I'll proceed with the question. So let us use your general rating as base values, because the parameters given based on base. Only one information is given. MVA, ABB generator value 100 MVA. The kV value is 8 kV. So I just connected these two as my base. So once these two values are predicted, means base current expression should be MVAB divided by root 3 times of kVB. So MV is 100 root 3 kV 18. Solve. So if solving, original base should be 0.207 kilo amps. 3007 வரும். 7 kilo amps நான் எடுத்திருக்கேன். ஓகேவா? Next, just fixing base value. The base value just to find out base current. So first substitution. To find the short circuit is the circuit. So in the problem, I clearly mentioned it is 5 cycles 0 to 360. 3 அப்புறம் add பண்றது வந்து 0 position 360. Likewise, we have 5 cycles. So in the 5 oscillation அப்புறம் தான் the power system should be in the normal position. Yeah. The circuit breaker clears the fault in 5 cycles, and so we can assume that circuit opens during the transient period of the fault. Therefore, all the current that may flow through the circuit breaker are maximum momentary circuit current. So maximum momentary short circuit current, subtransient fault current, and transient fault current. So these current flow may be happening in the opening of a circuit breaker. So we have to examine the currents are flowing or not. So if the fault exists even after 5 cycles, even cycles means if the fault is not cleared by opening the circuit in 5 cycles, then steady state fault current will also flow through the breaker. So my voltages in all the cases, such as subtransient, transient, and the steady state current, I just assuming as per unit, because problem they clearly mentioned the operating on no load with rated voltage. So no load rated voltage means all the levels you have the same voltage only. Angle 0 or 1 plus J0 per unit. So next one is the reactances are given. subtransient 20% is given. For transient 25% is given. And our steady state 110% is given. I just converting into per unit. 20 by 100, 25 by 100, 110 by 100. You have all your values in per unit. That is xt double dash, xt dash, and xt. So now you can easily calculate the subtransient fault current in the generator, excluding the DC offset current. So the mathematical expression is Ig double dash equal to Eg double dash by Jxt double dash. So Eg double dash we are assuming 1 at an angle 0. Xt double dash is J.2. So if I am minimizing, the subtransient fault current is phi at an angle minus 90 per unit. So this is my subtransient current. So next is my fault current in generator, excluding DC offset current. That is Ig dash equal to Eg dash by Jxt dash. So J 1 at an angle 0 divided by J.25. So the transient current should be 4 at an angle minus 90 per unit. So last one is steady state. So Eg by Jxt, 1 at an angle 0 by J1.1. So the value should be 0.909 at an angle minus 90 per unit. So these are all the various currents we obtained in the first part. So this is the maximum momentary current I said. For the initial rise of your voltage or current, you may have the maximum peak value of the voltage or current. So obviously, the current causing so much of the impacts to the power system. So the peak values, that is positive peak, negative peak. So the maximum momentary short circuit current is obtaining by multiplying Ig double dash by 1.6 to account for DC offset current. So we need the maximum momentary short circuit current. I am multiplying with 1.6 with 1.5. So I have 8 per unit. So the actual values is converted into base values by multiplying with your base current. So I have Ig double dash value multiplying with your base. Ig dash multiplying with your base. The steady state fault current multiplying with your base. And momentary short current 8 times of 3.207. So you have 25.686. So in this manner, you have to calculate your maximum momentary short circuit current in the circuit breaker. So that is the first part. The first part is over now. So now நம்ம பார்த்தது எல்லாமே வந்து பார்த்தீங்கன்னா முதல் பார்ட் தான் ஷார்ட் சர்க்யூட் கரண்ட் இந்த பிரேக்கர் இதை மட்டும் கண்டுபிடிச்சிருக்கோம் சரியா. So next வந்து பார்த்தீங்கன்னா we have to find out the initial symmetrical RMS current. So the initial symmetrical RMS current is nothing but subtransient fault current excluding DC offset. The same as that of your Ig double dash. So Ig double dash and IRMS are same. So phi at an angle minus 90 we determined earlier. So phi at an angle minus 90 கண்டுபிடிச்சோம்ல அது. So actual வேணும்னா IB ஆல multiply பண்ணிருப்போம். So when you multiplying with IB, you may get 16.035 kiloamps. This is the initial symmetrical RMS current. So subdivision B is over. So C is also central. To find the maximum possible DC component. So the maximum possible DC component of short circuit current in the breaker is the difference between maximum momentary current and the initial symmetrical short circuit current. So maximum short circuit current is 25.656 and short circuit current, that is RMS, is 16.035. So once you make the difference between these two, you may have the maximum possible DC component current. There's nothing but 9.621 kiloamps. So C is over. Next one is D. To find the interrupting current. So the interrupting current of the circuit breaker can be estimated by the transient current by multiplying with a suitable constant. So the constant value I just shown in the previous class table, selection of circuit breaker session, just shown the table. So in the problem it is mentioned as 5 cycles. So the multiplication factor is 1.1. So the short circuit interrupting current is 4.4. 4 per unit value of short circuit is 4. Multiplication factor is 1.1. So 4.4 per unit. That is the interrupting current. The last subdivision is interrupting MVA. So let us multiplying with your base current. So once you multiplying, that is the actual current is 14.113 grams. Last is to find the interrupting current. This is the formula. So per unit value of the pre-fault voltage is 1. Per unit value of the interrupting current is 4.4. Base MVA is 100. So totally 1 into 4.4 into 100. So 4.4 into 100, 440 MVA. So this is my maximum interrupting MVA in the breaker. So these are all the 5 subdivisions we have in the problem. So the first subdivision is somewhat complicated. Based on the first subdivision simplification, the subdivisions B, C, D, E are quite simple. So it is one of the most repeated university questions. Even the data also not changed or altered. You get the same data, you get the same values. The question is often repeated in university examinations. So try to remember the question and practice the question. Do you have any clarifications? Doubt is கேட்கணும்னா கேளு சொல்றேன். Do you have any doubts? Doubt இருக்குமா? நமக்கு வந்தா கேளு. Already there posted the attendance percentage in your groups. Third year students having a very lack in attendance percentage. So if you are not attending the one session, the percentage is so much different in your overall attendance. So try to attend all the classes hereafter. The past is past. So if you need attendance, if I want the examination sessions properly, I have tried the examination, means you have to attend the classes properly. Liking or not, it is no issues. Just be in class. Then only you will be going to appear for the examination. Otherwise, you didn't appear for the examinations. So this is my one of the needed instruction from my side is you have to attend the class. Okay. What if the participants is there? I think your class strength is 60. 43 participants is there. Try to attend the class. Shall I continue for the next problem? Is it okay to everyone? The problem is okay? Or want any clarification in the solution? Solution the clarification in the case. The PPT உனக்கு attach பண்ணிடுறேன். Notes second unit notes the entire row student கேட்டிருந்தேன். attach பண்றேன். நேத்து எனக்கு இதுவாகல. PPTக்கு பதிலா நான் இந்த third unit full material அனுப்பிச்சிடுறேன். மெட்டீரியலுமே அனுப்பிச்சிடுறேன். Just to refer last problem. இந்த மெட்டீரியல் வந்து கடைசியா ஒரு ப்ராப்ளம் சப்போர்ட் இருக்கேன். That is your circuit breaker problem. Okay. So we completed the fault analysis balance to fault problem using your Thevenin's theorem method. Z-bus method also we completed. Z-bus complete பண்ணிட்டேன். பார்த்தீங்கன்னா circuit breaker problem is over. The problem last class பார்த்தோம். ஞாபகம் Thevenin's theorem KVL அந்த மெத்தட் யூஸ் பண்ணோம். இந்த ப்ராப்ளம் பார்க்கணும். 9 to 10 மூணு லேப்ல உங்களுக்கு 10:30 மணிக்கு கிளாஸ் இருக்கு மேடம், எனக்கு முன்னாடியே கூப்பிட்டு அப்படின்னா 9 to 10 Next problem. You have two generators. Hope the screen is clear to everyone. Generator G1 and G2 are identical and rated as 11 kV, 30 MVA. They have a transient reactance of 0.3 per unit, 1 MVA base. Transformers T1, T2 are also identical and are rated 11/66 kV, 10 MVA. Have a reactance of 0.075 per unit to their own MVA base. Then the line is 60 km long. Each conductor has a reactance of 0.9 per kilometer. The three-phase fault in that fault F is 25 km generator. Find the short circuit current. So this is the one-line diagram we have. So based on the question, I just drawn the one-line diagram. We have two generators. Identical means same rating. 11 kV, 30 MVA, 0.3 per unit. Here also 11 kV, 30 MVA, J0.3 per unit. So identical means same values. And just like your transformer is also identical. So here it is step up, here it is step down. So the in between the transmission line. So the transmission line fault distance is given. So the length of the transmission line is 60 km long. The transmission line length on the 60 km. So enga fault வரணும் சொல்லிருக்காங்கன்னா the three phase fault should at the point F, which is 25 km from generator 1. So generator 1 la irundhu the faulted point 25th kilometer la I have the faulted terminal. So in this point faulted point you have to find out the short circuit current. So enna எப்படிங்கறத கண்டுபிடிக்க. So first I just converting the actual values into per unit values by performing the per unit analysis. So your G1, G2. So kV x per unit volt J0.3, kVB volt by kVB new, MVAB new by MVAB volt. So I make it J0.3 for G1 and G2. The T1 and T2 the same, x per unit volt kVB MVAB. So I have J0.225 per unit. Just like the transmission line. So it is a 60 km transmission line. So the line is split into two because the 25th kilometer I have the fault. So the 25 plus 35 is 60. So 60 minus 25 is 35. So I have to determine the reactance for transmission line separately. So 25th as well as the 35 kilometers. So J1584 per unit as well as here as J0.2218. So once you determine the per unit analysis value, try to draw the reactance diagram in the step number 4. So I have the initial voltage of 1 at an angle 0 for generator 1, 1 at an angle 0 in the generator side. I have the same reactance values because identical. So T1, T2 is also identical. I have the same value. Only one difference is here it is 25 km, here it is 35 km. So in between I have the fault current IF. So it shows that the circuit is divided into two meshes. மெஷ்ஷாக வந்துடுதா? இது மூணுத்தையும் ஆட் பண்ணிவிடும். 0.6834 இது மூணுத்தையும் ஆட் பண்ணுறேன். 2218 0.225 J.3 J 0.7465 ரெண்டுமே parallel combination. ஸோ அந்த parallel combination வந்து நீங்கள் ரெடியூஸ் பண்ணீங்க அப்படின்னா you may have the values J 0.356 65380 is the Thevenin value. V Thevenin is 1 at angle 0. It is a pre-fault voltage we are just assuming, and we have the short circuit branch IF. So as per your Ohm's law, IF equal to E Thevenin by the TH plus the F. That F is 0. So 1 at an angle 0 by J 0.3568. 2.80 at an angle minus 90 is the fault current in per unit. So if I need the value in kiloamps means I have to multiply IF with IB. 2.8023 and IB is nothing but NBAB divided by root 3 times of KVB. So the fault current should be 735.413 amps or 0.735 kiloamps. Okay, so this is the problem. We have the bus method. So bus method now already introduced பண்ணிட்டேன் இல்லையா? First case சொல்லியிருக்கேன். So இந்த problem proceed பண்ணோம் without considering the J point or 3 line. That's ஒரு case. 0.3 consider பண்ணி ஒரு case. நீங்கள் ரெண்டு கேஸில் வந்து சால்வ் பண்ணணும். You have the solution. Just to share the PPT or a PDF to you. Just refer it to the same cross elimination technique. Just eliminate all the values. So finally, you have 4x4 matrix. 4x4 or 3x3 down or 3 buses. Then 3x3. So it is your work. No exercise problem. The question is. உங்கள் ரெகுலேஷனில் அந்த கொஸ்டின் வரும் Z பஸ் மட்டும் கேட்க மாட்டாங்க. சப்போஸ் கேட்டாங்கன்னா எழுதுகிற மாதிரி வச்சுக்கோங்க. அவுட் ஆஃப் சிலபஸ்ன்னு இல்லை, இட் இஸ் அ பார்ட் ஆஃப் த ப்ராப்ளம். தேர்ட் யூனிட்ல ஒரு பார்ட். தெவினியன்ஸ் மெத்தடில் எப்படி சால்வ் பண்ணணுமோ அதுபோல் Z மெத்தட்லேயும் சால்வ் பண்ணுறோம். அந்த சால்வ் பண்ணுறதுக்கான ப்ராசஸ், மேத்தமெட்டிக்கல் ப்ராசஸ். நீங்கள் கேட்டாங்க அவுட் ஆஃப் சிலபஸ்லாம் சொல்ல முடியாது, கேட்டாலும் we have to answer. So just to practice the question using cross elimination technique, bring your original matrix. So the 3x3 matrix, you have to bring it back. So next, this is also one of the most important. The third unit, the 11 problems I am teaching in the online room session. The 11 problems is repeated so many times. ஒரு வருஷம் இன்னொரு வருஷம் மாற்றி ஒரே கொஷின்ஸ் தான் கேட்டுட்டு இருப்பாங்க, வேற எதுவும் இல்லை. 11 கொஸ்டின்குள்ள தான் வரும். சொல்லணும் என்கிட்ட. Anything you want to convey with me? Shall I continue further? Previous problem, do you have any issues? It is 2 generator, 2 transformers, fault in the transmission line problem. Have any doubt? Shall I continue further?
Yes, sir.
Thank you, ma. Okay. Just to complete the problem with this problem. The radial network shown in figure, the 3-phase fault occurs at point F. Determine the fault current. So the question is repeated most of the times. Many times the question is repeated. You have 2 identical generators with the different transient values, that is reactance values. Here it is 20%, here it is 12.5, but it is connected in a common bus, 11 kV bus. 11 kV bus, G1, G2 connected in parallel. And you have the 2 series transformer, T1, T2. So 11 kV is your primary side. Secondary side we have 33. So it is 11 bar 33 transformer. So in between the transformer T1 and T2, you have the overhead line. So the impedance value is 6 plus J10. The transformer rating is given 10 MVA, 10%. Likewise, our T2, primary is 33, secondary is 6.6. So it is step down transformer, 33 to 6.6. T2 is 25 MV, 8.7% reactance. So it is connected to a distributor. That is feeding terminal it is connected. So only I can say the term is F. So in the feeder terminal, we have to find out the fault current. The feeder impedance is given 0.5 plus j0.15 ohms. So இந்த சர்க்யூட் வந்து பார்த்தீங்கன்னா உங்களுக்கு வெர்டிகல்ல கொடுத்துருப்பாங்க இந்த கொஸ்டின்ஸ்ல. இந்த கொஸ்டின் வந்து ஹாரிசான்டலா கொடுத்துருப்பாங்க. எப்படி கேட்டாலும் உங்களுக்கு வந்து அந்த சொல்யூஷன் சேம் தான். Either you may get the figure in vertical format or horizontal format. The solution is remains same. So first, the one-line diagram is converted into a reactance diagram. So in the left-hand side, I just converted my reactance diagram. I have my generators G1, G2, which is connected in parallel. For the parallel of the generator, I have the transformer in series, first transformer. So after the transformer, I have the transmission line in series, that is overhead line. So next, I have feeder. So from feeding point to this point, I have my pre-fault voltage VPA. In general, we are assuming 1 at an angle 0. So now we need to perform the per unit analysis and substitute all the values. So notations எல்லாமே எழுதிருப்பாங்க. XT1 என்ன, 2 என்ன, T1 என்ன, 30 என்ன அப்படின்றது எழுதிருப்பாங்க. So I'm just considering my generator value as base values. So 10 MVA, 11 kVA is my base. So just assuming pre-fault voltage as 1 here, PPF is 1. So generator values, base values are same. So no need to perform per unit analysis for G1 and G2 as usual. So 20% is given, the value is 0.2. Here it is 12.5%. So 0.125. 0.125, not 15, 0.125. So for transformer, so here also it is same, it is identical, so 0.1. After the T1 only the value changes, that is kVp changes. It is kVp on LT side change. So 11 into 33 by 11. So 11 cancel 33. So ZB is kVp square by MVAB, 33 by 10. So 33 squared, 109 you have. The actual impedance given in the problem is 6.J10. 6.J10 divided by 108, 8.9. 0.0551 plus J 0.0919 per unit. So next one is reactance of T2. So hereafter my kVp is 33. So T2 is 0.087 into 33 by 33, 10 by 25. So the value should be 0.0348 per unit. Next one is to find the impedance of the feeder. So obtain a change of base in kVp and LT. So 33 into 6.36 by 33. 33, high side get cancelled, you have only 6.6. So here also your base value is 6.6 square, MVAB is 10. 4.356 is my the B. The actual by base. So for the feeder impedance is 0.5 plus J 0.15. So just divide it, you may have the value. 0.1148 plus J 0.344 per unit. Now you have to substitute all the values in the circuit. Just substitute it. J.2, J125.1, OH line value, transformer T2 value, feeder value. Here it is ZTH. These two values are parallel. These values are in series. Once you are simplifying, you may have 0.1699 plus J3379. So if you are converting into polar, 0.3782 at an angle 63.3 per unit. So V Thevenin is 1. So it is assumed it is a short circuit fault. IF equal to V Thevenin by TH. 2.6441 at an angle minus 63.3 per unit. So if you need the actual current means MVAB divided by 3 times of KVB. MVAB directly confuse பண்ணிருக்காங்க. No need to consider this KVAB. Just substitute the value in MVAB. MVAB value divided by 3 times of KVB, you may get 0.847 kiloamps. So on the 0.847 multiplying with your 2.648. You may have 2.313 at an angle 63.3 lamps. So this is the fault current in the feeder. Yeah, this is the ரொம்ப important problem. So feeder fault current IF determinant. One thing you needed is you have to perform the per unit analysis. The per unit analysis is substituted in the circuit. The circuit is minimized with the help of your Thevenin's theorem. In Thevenin's theorem, three parameters needed: one is Z Thevenin, one is V Thevenin, one is the load. Instead of load, we have the short circuit branch. So the conventional method of your circuit theory, I just simplifying my power system networks. So you may ask, why sir we learned the circuit theory in not second and subsequent? For this purpose only we are learning the circuit theory. For the application of electrical engineering, the circuit is one of the two. Not only this paper, all your papers you may utilize your circuit theory paper. So circuit fundamentals is much needed for your electrical engineering wherever you go. If you are joined in a job also, you need the circuit theory knowledge only. So without knowing the circuit theory fundamental concepts, you couldn't survey in the industries or even IT sector also. So IT sectors also they are recruiting technical division. So wherever you go, you need the circuit knowledge and electrical knowledge. Then only you can survey in the society. Be in it. Seven. ரொம்ப சிம்பிளான ப்ராப்ளம் தான். நெக்ஸ்ட் கிளாஸ் பார்ப்போம் இந்த ப்ராப்ளம்லாம். Have 2 to 3 problems in your session. இந்த ப்ராப்ளம் தான் நடத்துறேன் இப்போ. ஃபர்ஸ்ட் நம்ம பார்த்தோம் இல்லையா, 5 சைக்கிள் சர்க்யூட் பிரேக்கர் இதான் நடத்துறேன். நோட்ஸ் பேஜ் நம்பர் வந்து 104ல இருக்கும். ஸோ தியரி வளவலன்னு இருக்கும், உனக்கு புரிஞ்ச இதில் நீங்கள் எழுதிக்கலாம். எல்லாத்தையும் அப்படியே தியரி ரீப்ரொடியூஸ் பண்ணணும்னு அவசியம் இல்லை. சென்டென்சஸ் வந்து உங்கள் ஓன் வேர்ட்ஸில் ஆக்சுவல் அந்த ரெப்ரசன்டேஷன் இருக்கும், மாறாமல் அப்படியே கொடுத்தீங்கன்னா போதும். இன்னும் ஒரு 4 ப்ராப்ளம், 3 to 4 ப்ராப்ளம்ஸ் இருக்கு. ஸோ ஃப்ரைடே செஷனில் பார்ப்போம். தேங்க்யூ.
Thank you, sir.